Okay, example 2. First thing I want you to notice about this before you even worry about the domain is we have a not greater than or equal to symbol. We don't want to graph negated inequalities. So the first thing I'm going to do here is I'm going to transform this into a good inequality. So I'm going to keep x the same, I'm going to keep 3 the same, I'm going to translate that into what it truly means, which is what?
X is less than 3.
Greater than.
Perfect. Less than.
Oh, I mean, yeah.
No, the one pointing that way, right? Yep. Okay, so our choices are this, this, and this, right? Those are the 3 things that could possibly happen with numbers. And when it has a not through it, it's being not greater than or equal to. The only thing left over is less than. All right? So that's priority 1. Always make your inequalities into a regular, nice, regular inequality, not a negated inequality. Next, we want to graph based on the domain of the set of integers. Like the set of integers, you don't have to write these set of integers down every time, but just so you can look at it. Alright, there's a set of integers. They start at negative infinity, go all the way up to all these numbers, negative 3 through 1, 0, then 1 through 3, and then 4, and so on. So the dot, dot, dot means continue on in that direction forever. The dot, dot, dot means go that way forever. Follow the same pattern, hitting every single non-fractional number, right? I want numbers less than 3. Give me a number in this list that's less than 3.
Negative 3.
Alright, anything else?
Negative 1.
Okay. Negative 1 is. Okay, what else?
Negative 1, 0, 2, negative 2. 2.
Alright, and the dot, dot, dot was where the negative 4 was, and so on, right? If I keep going this way, are there any other numbers going this way that I'm going to hit that are less than 3?
No.
No. Is 3 less than 3?
No.
No. Alright, so here's my point on graphing the set of integers on a number line. Line with 2 arrows, how many dashes?
5.
5 or more. I'm going to put 3 in the middle. 4 and 5 are bigger, 2 and 1 are less. Alright, now, I'm not, usually if I'm graphing for a set of real numbers, I'm going to put an open circle of 3 and shade to the left, right? I don't need an open circle when I'm dealing with a set of integers. There's always a first number that makes it true. That's the first number that makes it true. 2 is less than 3 and it is an integer. So I'm going to put a closed circle at 2, I'm going to put a closed circle at 1, and I'm going to shade the arrow in to demonstrate that that pattern continues on forever in that fashion. If I were to take this number line and pull it this way, and as I pull it, numbers keep on appearing, this is telling me that as those numbers keep appearing, they're going to be
So in ours,
shaded just like this.
we dot all of them except for 3 and 4.
Exactly, yeah. So if I got more numbers on your sheet than I have on this board here, for example, if it goes like this, let's say we have 3, 4, 2, 1, 0, negative 1, negative 2, negative 3, right?
Why can't we just scribble a line?
You don't want to scribble. You want to scribble the line, Parker?
Yeah.
All right.
Because integers have to be they can't be point something, so they can't be in between negative 2 and 1.
What she said. Okay. So when you scribble a line, what you're doing is saying I'm including everything on the line. Okay. So I start scribbling the line like this. So open circle, shade, right? That blue is including 2.1 and 1.97 and 0.55513 and negative 0.0724. Right? Those aren't integers. Okay, we're supposed to be graphing integers only. So again, it's a filter system. Why won't that disappear? Is my board acting up again? Pretend that blue line isn't there. All right. But what the integers, the domain is a filter system. So where normally x is less than 3 looks like this blue graph, right? We're putting it through a filter and it's saying only numbers that look like this get to be graphed. So we're graphing only those numbers. We're putting closed circles on each of those numbers to represent the graph we're looking for. So we're looking for this red graph. And again, as many numbers as necessary on your number line if it's already drawn for you. If you draw your own, give me at least 2 numbers that are dotted before you put the arrow. If you just put like 2 and then put an arrow this way, I pretty much know what you mean, but not really, so make sure that you're careful with that.